Let's look at using some technology to help us sum some series. And notice that when we have explicit formulas like we do for the sum of a finite or arithmetic or a finite geometric series, if we have a formula like that where we can find an explicit formula, then we can easily compute the sum regardless of the number of terms. However, even if we cannot find an explicit formula for the sum, then if we have a finite number of things added together, a finite series of constants, then we can always compute a sum. It's just basic arithmetic. Although, if there's a large number of terms, this could be extremely tedious. So some calculator or computer program is extremely useful if we cannot find some explicit formula. So let's look at some technological ways of computing sums of finite series. Let's try, first of all, a TI-84. So we want to compute the sum from k equals 1 to 100 of k squared over 2 to the k. Again, we don't have a nice explicit formula for that sum, so we'll need to actually compute all 100 terms and then add them up. Now that's extremely tedious, a lot of nasty arithmetic. So a calculator is extremely helpful. So let me show you how to do that on a TI-84. So we start by creating the sequence as a list. So that's under list here. And we go to operations. That's number 5. You can either down arrow till we get to the 5 and hit enter, or I can just push the number 5. Sequence. Now we get to here. We can actually put any letter we want in here for the variable. I'm just going to push this button, which is going to be easiest one. I'm actually in sequence mode, so it's the sequence variable in, but if it turns out to be X for you, you don't have to put it in sequence mode to do this. That's for the variable. Now the expression up here, we've got to work that out. It's actually in and then square it and then divide that by 2 to the power, well, k, but here it's going to be n. Now, we don't have to always just add up the first so many terms. We can add up any sequence of any series of these. We're going to start, though, on this one with the first term and add it up to the 100th term. And you can actually easily add up every other term or something by putting a different step here, but we're going to just use step 1. And then I'm going to hit paste. I'm sorry, this is not adding them up yet. This is just going to create the sequence. So the sequence, we can just kind of do some of it by hand. If k is 1, that's 1 square over 2 to the first, that's 1/2, so that's 0.5. Then we put in 2, that's 2 square over 2 square, that's 1. Put in 3, that's 3 square, which is 9 over 2 to the third, that's 9/8, which is 1.125, and so forth. There's actually 100 things in this list. And now, if I put my cursor up here, I might be able to scroll across here. I could also take this, you don't have to do this, but let me just show you something. I could say store this as, say, L1. And now if I go to stat edit, I can see it, and I can scroll up and down and see as many of these as I want. That's not necessarily necessary for computing a sum, though. So now, once I have my sequence, whether I've stored it or not, either it's my previous answer or I've got it stored, then I can go to list here again. This time go to math, so I'm going to go left arrows faster, and select number 5, which is sum. And I can either say sum of my previous answer, or since I've got it stored in L1, I can say sum of L1 and hit enter, and it's going to give me the sum, at least approximately, is 6. So the best abilities of this calculator, that sum is 6. Now I can do the same thing on a TI-nspire calculator. And here it is. Okay, let me, I've already worked it out here, but let me work it out again. On an Nspire calculator, you have templates here that we can use. And they're found under this button right here. So if you click on that, you got some different templates. And if you notice, there's one for sum. So I can click on that. I can use whatever letter I want. Say I used K when I wrote it, so let's just use it again. K equals 1 to 100. And the formula is a fraction to start with. And the numerator of that fraction is k squared. And the denominator of that fraction is 2 to the power k. And we can hit it. And look at that. It tells you the exact answer. That's exactly what it is. It's not actually 6, but it's actually 6 to many decimal places. So if I tell it to take that answer and give me an approximation of that, it also says 6 as well. So there's the exact answer for that sum. And there is the approximate answer is 6. And of course, 6 is accurate to many, many decimal places. It's actually a little less than 6, but not by a lot. Okay? And so there are at least some TI calculator ways of finding that finite sum. So as long as it's a finite sum, we can do it like that. Now, what we're really interested in and where we really get into doing some calculus now is summing an infinite series. We'll get to that in the next video.